Hello, everyone. Welcome to another episode of the Day Zero podcast. This is episode 35. I'm Spectre. With me is Z. Before we jump into topics, I'll reiterate what I said last week. We're happy to take questions and stuff like that, especially because these weeks are likely to be a bit less content-filled than usual as this virus stuff goes on. So you feel free to ask questions like whenever you want. We'll that way
I
we
don't
can
know if
pad
I
it out a little bit.
completely agree there. I mean, as time goes on, I'm going to hope that, some bug hunters start spending maybe a little bit more time bug hunting as they're stuck in their house or, stuck
That is
isolating.
absolutely a
So,
point. I mean, that's a point. We may see more exploits and stuff like that, but I know, the white papers and stuff that we cover from, universities and stuff like that, those are kind of, dead in the water for a little while because the universities are shut down entirely. So, we may see more exploits, but I think we'll see less research stuff, which is some of the more discussion-heavy stuff, so that's why I think we might be a little bit shorter.
yeah, no, and
So,
I mean, we want to welcome questions anyhow, so
yeah,
not going
for
to
sure.
complain there.
Yeah. Yeah, just wanted to get that out of the way, though. So we'll jump into some news. We'll start off with some controversy, actually. Some of you may have heard of it. It's about some vulnerabilities in Netflix that can allow man-in-the-middle attacks to steal session cookies.
Well,
So
so,
there's two
not quite.
issues
It's
here that allow it.
Netflix ID cookie. There's the secure Netflix cookie, which is separate from that. Which is used
Yes,
for
yeah, there is.
well, in theory, it's supposed to be separate from that and used for the authentication. Netflix ID shouldn't be used, but so it's not quite like it's not as simple as just saying session cookies. Netflix is a little bit more
Fair
complicated than
enough.
that.
Yeah.
So go on.
But yeah, basically, it seems one of the issues is some of their endpoints, they use HTTP instead of HTTPS. And the second issue is one of those session cookies that you mentioned doesn't have the secure flag set, so it can be sent over unencrypted channels. The vulnerability, though, wasn't what was super interesting about the article. What kind of made the story blow up is there's some drama around it because the vulnerabilities were initially reported through Bugcrowd, but they were classified as out of scope and they were rejected. So he went to disclose them and he put out a tweet and a YouTube proof of concept. And Bugcrowd reached out to him and said, "Hey, this is an unauthorized disclosure and take it down immediately." He complied with it. And several days later, Bugcrowd was like, "We dismissed it because it was a duplicate of a previous report." But what seems really weird about that seems to be a lie too, because Ars Technica apparently got transcripts from the researcher and the Netflix employee that he was talking to, and they said it wasn't a major issue because it required an attacker to have a man-in-the-middle position, and they wouldn't be able to take over the account because they can't change the passwords or the email or any credentials or anything like that. They can just log into the account and watch videos, but they can't hijack it basically. Um, so yeah, it seems very all over the place. It seems Bugcrowd can't seem to get their story straight. The issue is a low impact issue. It requires a high level of access. It requires that MITM position.
Well,
And like the
so
Netflix
here's
employee
my
said, you
thing.
can't take over the account, but the handling of this is just really bad. But yeah, go ahead.
Yeah, so the issue here, they're missing the secure flag. That's the only thing. It's missing the secure flag specifically on this the Netflix ID cookie, I believe it was. I should have it written here. I'm just not seeing it in my notes. But they're missing the secure flag on that. The thing is, though, the Netflix domain uses HSTS, strict transport security, I want to say. Basically, once your browser sees the HSTS header, it will only interact with the website so long as it hasn't expired with HTTPS. And in order to log into Netflix, in order to get this cookie, you already need to have interacted with the main domain on Netflix. You already need to have logged in, so you're already going to have seen this HSTS header, which means you're not going to be forced to interact with the Netflix domain under HTTP. So you need an attacker who's somehow able to redirect you very early on, before you've ever seen the Netflix page, essentially. Or at least that's kind of how I initially understood this. It's not quite correct. So the HSTS doesn't have the include subdomains flag on it. Also doesn't preload, so that's another thing. So you kind of mentioned there are other domains that aren't using HTTPS, which isn't quite accurate. So they're using HTTPS, but they just redirect. So you get the HTTP request in, it redirects to HTTPS. So the issue without the secure flag is those cookies are still going to be sent to subdomains. They are scoped to be sent out to the subdomains. So even though you can't use the main domain, so www.netflix.com, because the acts will go over HTTPS because of HSTS. Other domains, so in the example, they use this Orca API, or Oka, or something like that. Yeah, Oka API.netflix.com. And so,
or could be a lot cooler.
Yeah, so that doesn't use HSTS. So it's able to get that HTTP subdomain out there, although it does redirect you to HTTPS. So that's where they're kind of able to exploit, get that cookie sent, even though Netflix does have some mitigations there. It is still, as you mentioned, it's a high level of access need to actually hit this. You need somebody that's able to intercept your traffic, essentially. And that's not as common as it once was. You used to go to like your local coffee hotspot or like Wi-Fi hotspot, like a coffee shop, and you would have essentially an open Wi-Fi. Anybody could see all your traffic. Nowadays, it's a lot more common to see isolation on those public networks. There's a bit more knowledge around how to set up a Wi-Fi to add in some of that security. So that is used. So you're definitely limited if you're at home where you're probably going to be watching Netflix. There's very few attackers that are going to be in a position to man in the middle, but not in a position to do something more damaging. Because I could give it with the advent of IoT stuff. That would probably be one way this could be exploited, is you compromise the lights, like the bridge or whatever system's in place for that. Compromise that and then compromise the rest of the network. So there are ways you can maybe hit this, but I mean, Netflix does have some mitigations in there. Like, I could understand an initial response to maybe this isn't an issue we're going to care about. There are definitely a lot of companies that do have right in their scope information like, secure flag, HTTP only flag are issues that we do not care about on cookies. That said, I did look at their scope, and that is not the case for Netflix, or if maybe it was the case and they removed that. But it's definitely not in there anymore.
I mean, here's my question. If it's such a low impact issue, which, the more we talk about it, the more it seems like it's like a very low impact issue, then why do they have such a problem with him disclosing it publicly? You know what I mean? So
that was Bugcrowd that came out for the disclosure. And that's part of the terms you agree to when you start working with Bugcrowd. I do think the researcher was in the wrong for that. Now, I do think Netflix is in the wrong for rejecting it also. I do think that that's an important issue. And one of the aspects that didn't seem to be known by Netflix, at least when it was rejected, was they did mention that they needed a further cookie. They need that secure Netflix cookie. And this research showed that no, you could log in using just this Netflix ID. Or you can at least get onto the account using just that. So I mean, I can understand where Netflix thinks, okay, like this is a cookie, but it doesn't need to be secured because it doesn't provide access to anything, whereas they were mistaken in that. I could understand where Netflix kind of comes from in thinking that and then rejecting it. Once the researcher had shown that, no, you can do something with this cookie, that should have been where it was accepted. Going back, though, with the disclosure, that is part of just Bugcrowd's general system. Anything that you submit to them, you're under a non-disclosure for. You can
even if it's rejected.
Even if it's rejected, anything that you submit to them,
I don't agree with
goes
that.
through with that.
I don't agree with that. I think that's dumb. I don't like that at all. I don't know what your thoughts are on it, but
so that comes back to my thoughts on the disclosures in general, where I do think companies should be able to decide how things are disclosed. Like as researchers, I think we should respect the companies enough that at least they're opening up some of the testing to be done. At least they're making an attempt. Now, with a big company like Netflix, I can definitely kind of hold them to a higher standard and agree with you that basically they should have a lot more transparency, especially like you reject it, it can go public. Like it's a non-issue, then there shouldn't be an issue with disclosing it. That said, just as a general rule, I think as researchers, we need to be encouraging companies to have these bug bounty programs. And you don't do that by basically doing a screw you to the company by disclosing things when they clearly don't want you to. And at the same time, with Bugcrowd, whether or not you agree with that being their policy, that is their policy that you do agree to when you join.
Fair enough, but I think it's unreasonable to, like, if a company is not interested in a report and they're not going to address it, then I think it's no longer in their hands whether or not it's... I think they kind of give up that...
Yeah, no, they give up the right to, protecting that information.
That's what I was looking for.
Yeah, no, I can agree to that. Like I said, I kind of have I'm kind of split on, I do want to respect the company. At the same time, like, I do agree with you that I think things like that, like when they reject it as this isn't an issue, you don't get to say it's not an issue and then try and prevent people from knowing about the issue. Now, to be fair, it was Bugcrowd that tried to bring it down. It wasn't Netflix.
So it's a bit weird. There's definitely a communication breakdown there. It's weird.
Yeah.
Yeah. So, I mean, overall, I think it's just a shitty situation. Like, I think it's unreasonable that Bugcrowd expected that request to be respected, but that is a fair point that it is part of their policy, and the researcher did agree to it when they, signed up and submitted the report. So, I'm taking my stance back a little bit. I think that is a fair point to bring up, but I don't agree with that overall idea. But then again, if you don't agree with that, then you probably shouldn't be submitting through Bugcrowd either. So
and one thing, just jumping back on the actual issue itself, I will just mention, like, it's a very low risk issue. It is still a risk though, and like it is a best practice to use the secure flag. Now, I'm not sure if internally maybe you shouldn't, like, maybe there's just an issue with the fact that the Netflix ID cookie did allow you to do more than they anticipated it to. But I would argue that, it's still best practice to do this. So while I have been downplaying the actual issue in terms of how you're going to exploit it, it's still definitely best practice to be using that secure flag on cookies. And I mean, I really don't see why they wouldn't also be preloading for HTTPS and just generally using that everywhere rather than just doing the redirect. The redirect is going to help with most cases, but these cookie leaks are something that can happen too, which using preloading would help. Yeah, I will also really quickly, Cat 3009 out of chat. That's the problem with all bug bounties. They can just say it's a duplicate or it's out of scope, and you as a researcher can't verify anything. So I know on HackerOne, at least I've seen, I think we've even talked about some of the reports. I don't think we actually called out this aspect. But what they will do is it's a duplicate, and then they'll attach your ticket to it. They'll create a relationship between the two tickets, basically saying this is a duplicate of this ticket, and you'll have access to see that ticket.
Yeah. Yep, we've seen it a few times.
So I mean, it's not that there's no way to validate it. It's definitely a concern, though. I mean, a lot of people are concerned, like, oh, is this company just going to try and screw me off these vulnerability reports? And I'm not sure. Where in this one, because I actually didn't take note. Like, I remember taking note of what you mentioned, or of this first bit. Taking note of the fact that it was unauthorized disclosure. Taking note of the fact that they didn't think it was a full issue, but I do see the duplicate bit in there now, so I guess never mind what I was going to say there.
I think I will say, like, I think we've had this discussion before on one of, like, the first podcast episodes we had, like, one of the first, like, 5 or something like that. And what we essentially kind of talked about is that if bounty platforms were doing that, or if, like, vendors were doing that and saying this issue is a duplicate, eventually they would be found out, and that would be, like, very damaging on their their bounty program's reputation. So I think companies are hesitant to do that, as much as it would be technically in their best interest to screw reporters out of their payouts. I think they know that it would be quickly discovered and it would be extremely bad PR if that was discovered.
Yeah, and I guess
So
another thing is that let me double check, but Bugcrowd does it. So Bugcrowd does mention that, that like the average payout, and HackerOne does the same thing.
Yeah.
So you do kind of have that to go on with the fact they do pay somebody or some people. Obviously, that can be gamed a little bit. Like only paying out the big ones or something and saying everything else is duplicate.
But you'd have to be subtle with it, because if you were too obvious, it would be found out very fast. So I don't think it's real. There could be some vendors out there that are doing it, but I don't think it's like a widespread problem, at least.
No, at least not with those that go through these programs like HackerOne, like Bugcrowd. It could be a bit more of an issue with a company that just kind of has a random bug bounty, although that's kind of less common now that Bugcrowd and HackerOne have kind of made it a lot easier to get started with a bug bounty rather than need to run it all in-house.
Yeah. So with that, I think we'll jump into our next topic. Our second news story is called "Where Is My Train? Tracking to Hacking." So, a bit of a fun title.
Yeah, well, so it relates with the last one. Like, the main thing is that Google rejected this issue initially. So that's where... So there's two issues in this report. One's a SQL injection. Basically just says it's there in the train date parameter I don't have the parameter written down. Train day has a cross-site scripting in it, which is the key issue here. They just kind of mentioned the SQL injection in passing.
Well, there's also the issue of no authentication too, which allowed them to exploit this.
Well, yes, there is the IDOR.
Yeah,
which is another thing. But I guess we'll say with the whole issues, or before I go there, actually, let me just mention, I really don't like the way this one's written with all the memes.
Oh, I know, it was a bit hard to read.
It was a bit much. Like, you don't need to have a meme of how you feel every paragraph.
Somebody told me this before. If you see a lot of memes in a write-up, it's usually indicative of the author thinks that their write-up is very dry and they have to spice it up by adding those memes in there. Which, if that's the case, then you probably need to refactor your write-up, not just throw in a bunch of memes, right?
Yeah.
That's just something I've, because I once did a write-up that was similar to that. It had like a few, joking pictures in it, and they're like, you generally don't want to do that. People kind of in the security community will look at that and it'll kind of degrade their opinion of the write-up, I guess.
Yeah, I mean, it's one thing to have one or two in there if you've got a long write-up on like some key points, but it's another thing, like I mentioned, this one have very consistently.
I'd rather diagrams than memes, put it that way.
Yeah, no, and I agree. I don't necessarily think it's too bad if one or two. I'm not saying to put one or two in. I'm just saying it gets excessive.
It's acceptable. Yeah.
Yeah. That said, let's go on to the actual point. Cross-site scripting in a Google acquisition. Essentially, it was tracking when your train's going to come by or where it is. So what ended up happening here is it seemed like a pretty straightforward cross-site scripting. Train day parameter did injected a attribute that did on mouse over, did an alert. Simple enough. Seemed pretty straightforward. Didn't have to do any escape. Didn't have to do anything funny. Reported that, and it got rejected by Google with the statement, thanks for the report. We think this issue might not be severe enough for us to track it as a security bug. While the exercise does trigger, the website does not support signing in, and as a result, there is no session cookie for the attacker to steal. And with that, so I guess I will jump back, as Spectre did mention, you had access to a panel, an internal panel, which is where this cross-site scripting was, which probably should have been behind some sort of authentication rather than just being a secret page. So I will mention that, but jumping onto this, I kind of thought it was interesting that Google rejected it over there's no session cookie, therefore an attacker can't do anything with this cross-site scripting. And I mean, in general, your session cookies should be protected by HTTP only. It's a flag you set on the cookie when you set it, so JavaScript can't actually interact with it. and that should also be protecting it. So by that logic, you could essentially say that any website that uses HTTP, which isn't the case. Obviously, it is different when you do have a sign-in. You do have more pages you can interact with as that user. But one of the things I always go to when talking about cross-site scripting is you can serve malware using cross-site scripting.
Yep.
And that just destroys the reputation of a company. You know, there's this link floating around that's yourcompany.com, and it's serving everybody malware, but people are trusting it because it's, you know, your company. So it damages the reputation. That's, you know, just, you basically have no other need besides having cross-site scripting.
You don't easy to make drive-by pages.
Yeah, which is what this author went and did. He made a phishing page using it, which is another fine example of something you could do with cross-site scripting, even when you can't log in, is make a phishing page, have them send you all of their credentials. A ton of people will fall for that if they kind of expect to be able to log in, or it seems like a reasonable feature.
Yep. And it's under the legitimate domain, so, like, I'll be honest.
Yeah, under a domain.
It would be hard for me to question it if I saw it. So, I agree with you. I think it's a serious issue. I think it was silly that Google rejected it out of hand.
Yeah, and I mean, so they did eventually accept it, to be fair to Google, but yeah,
this one has a lot less drama around it. There's no drama around this one.
Yeah, less drama. Story. I just figured it kind of relay with the last one there about it being rejected. That said, actually, touching on the last one, I don't think it was really worth like an Ars Technica write-up about it. Like, I don't think the vulnerability is that impactful that should have had, you know, a news report for it.
Well, I think it was less about the actual issue and more about the situation around it, like how it was handled. So
yeah, well,
I think it's just reasonable.
I get, like, I mean, obviously they did it, so it was reasonable, but or at least it was something they could do. I don't know. I just
it's, like, justified. You know what I mean? Like, I think it was more centered around the actual issues around it than the vulnerability itself.
Yeah, I felt like it was a bit overplayed. Here's the Netflix account compromise Bugcrowd doesn't want you to know about.
It sounds a lot more impactful than it is.
Yeah.
It's a bit clickbaity.
But yeah, I guess we've already moved on from that topic, so it won't take us too far back with that. With this one, though, I mean, that's the gist of it. There's cross-site scripting that got rejected.
Yeah. So another one where the issue itself is fairly trivial, but I thought the attack was kind of cool. Like writing a phishing page with the XSS. You know, it's a good demonstration.
Another pretty common demo.
Yeah. Our last bit of news is on Rocket Skylake-S, and it's basically one line of text from this diagram from the Rocket Skylake-S feature update, and it's essentially saying Intel Software Guard extensions has been removed from Rocket Skylake-S CPUs and platform. Now, I wanted to bring this up because we do talk a lot about SGX on this podcast in the past.
And we will be later this episode.
Yep, we have a topic later that touches on it. But people are wondering if this is kind of the beginning of the end for SGX. We've seen over the last little while, there's a lot of issues with it. I think even on the last podcast, maybe, I was saying that it might be time to just throw it out in favor of something new, because there's just too many glaring issues with it.
Yeah, well, I mean, it is such a cat and mouse game, though. I mean, you're dealing with an attacker that has hardware access, in theory. It's a hard problem.
It's a hard problem, but it has some architectural flaws that kill it right from the gate. Like, there's nothing you can really update or anything to fix it. It's kind of it's a design issue, right? Like the one we were talking about with the IOMMU being initialized later on, so you could do DMA writes to the page tables. Like, there's certain design decisions that seem really silly. So that's why I think that SGX, it's possible that it's getting thrown out and they're working on something else. Or maybe not even working on something else. Maybe they just give up on the TTP
I saw
area.
some people kind of speculating that it'll move to just being on Xeons. That it'll just be more of a enterprise level feature.
I could see that. So it wouldn't be used for like DRM, for like consumer DRM, I guess. Yeah, so to be clear, just for anybody listening here, this is just a leak of what Rocket Skylake-S may feature. It's not a confirmed leak. It's just a leak.
Yeah, I was going to say Netflix wouldn't comment, but Intel actually did, give a non-comment.
Oh, I didn't see that.
Well, somebody just asked on the forums, like, hey, they noticed this rumor, and basically their response was, we can't comment on roadmaps via this forum. Please continue to monitor Intel.com. So basically, Intel's saying nothing.
That's basically, I cannot confirm or deny that accusation without permission from the secretary. Got some Mission Impossible lines going on in there.
Yeah, so while I believe, it's fairly likely, it is worth pointing out, this is just a leak mentioning that it's being removed.
Yeah. I mean, yeah, I'm thinking that we might be seeing the end of SGX. I think they're tired of getting hammered on it.
I don't imagine that whatever else they bring out is going to be more secure. I mean, have we seen... Okay, yeah, we have actually. There is... The names escape me right now, but there is at least one. I'm not sure if I'll be able to pull it up here.
Can you repeat that?
So I was going to... Yeah, sorry. I kind of cut myself off with that. I was going to kind of raise the question, are there any trusted execution environments that have remained fairly secure?
I think Trust Zone's remained pretty good. Because it's used for, pretty much all, modern Android phones and stuff like that. And,
Yeah, no, there's another one from phones I was thinking of. I just can't recall the name right now. That's what I was mentioning there. I can't
PSP
think of
maybe? AMD PSP? Although, there were some issues with that, too. I remember seeing it at Chaos Communication Conference, so...
For like I said, I can't remember. I just remember its name started with an E, but it doesn't matter. There are some... It has been done in a decent way, or perhaps it just hasn't been looked at enough, but... Oh no, I'm going to leave this as, it's a hard problem to solve. That's why I mentioned earlier, it's that cat and mouse game. So I could see them replacing it. I could see them removing it too. Yeah. That said, because AMD does have it, they're probably going to want to remain competitive. So probably maybe not remove from the consumer level.
That's why I kind of question if we will see it removed. And yeah, I agree. Trusted execution environments, they do have a very tough threat model to deal with because of how much access the threat model has to account for. Yeah, but SGX is definitely, I would say, almost certainly is the worst trusted execution environment out of all the ones that we've seen. So I think we may see the end of SGX, but I don't think they're gonna shy away from doing any trusted execution environment stuff in the future. I think they perhaps are working on something new that we might see in the next few years. Keep a lookout for it.
Just a new name for it.
Yeah. Or maybe the name comes back, but it's, completely redesigned or something. We'll see. We'll jump into some exploits, though. Our first exploit is an issue in an Adobe library. That's a very big surprise, I know. Adobe is very secure, as we've seen in the past. And it's being used to target attacks against Windows 7 machines. Technically, the issue exists in more than Windows 7. It exists in 10, for example, but they're confident it's not exploitable in 10 because of added security mitigations that have come along since Windows 7.
Well, so that, I read that, it's okay, so, maybe they've... I thought, mitigation, ASLR, you had a static file, so you couldn't actually get the addresses and dynamically get them in there or something. But if you scroll down, way down there, you've got a successful attack could only result in code execution within app container sandbox context with limited privileges and capability. So the exploit still works just fine. It's just sandboxed. So you need to chain it with the sandbox escape.
Okay, so that is actually more impactful than I thought originally. They downplay it a lot.
Yeah, I thought that really downplayed it because it sounds like the exploit doesn't work. Whereas, and to be fair, I want to say a lot of the type rendering and stuff in Windows 7 was still coming out of kernel land. So very high privilege compared to being in a sandbox. So to be fair, it is still a lot less. Yeah, actually it mentions things processed in kernel mode, or some were processed in kernel mode.
It's common. I think we've even seen iOS a little while ago. They had a vulnerability in their iMessage stuff, and it was a like Unicode character, whatever, that they didn't account for, and it would boot loop phones. And the issue was in kernel because I think a lot of people or a lot of software put the font rendering stuff in the kernel because it's faster. You don't have to deal with the context switches and
that's
stuff
exactly
like that.
why it was in the kernel like that.
But
it has a historical
it's a bad trade-off,
reason.
I think. Yeah, it's a bad trade-off. I don't think it's worth it anymore. I think systems have gotten fast enough to the point where you can start sticking that in userland without a performance hit that's noticeable. So yeah,
although
it's fair that it's getting moved.
While that's true, I mean, at the same time, you've got so much legacy code. Like, it's hard to just move something out.
Oh,
I get why it took so long. That said, I mean, that is a big difference here. With Windows 10, it is sandbox. In Windows 7, I believe it's kernel code.
Yeah. So not
and I mean, this is remote. So essentially, it's a custom malicious font parsing issue. So like you can have that issue come up over the network. If you have like a network drive, have the preview frame. Somebody clicks on the file, sees the preview, that loads the font, and you've got it like remotely. So it is worth mentioning kind of that attack scenario exists for remote exploitation. But yeah, I mean, the fact that, I don't know, just the way they explain that with the mitigations, the possibility of code execution. Yeah, because I mean, it sounds like you get code execution, it's just limited code execution.
Yeah, they make it sound like you can't get code execution, like it's impossible because of mitigations. So
yeah,
I think they should clear that up.
So I thought, well, technically they do clear it up the bottom.
Clear it up top. One thing that's worth pointing out, though, is there is actually no security patch out for this. They have a workaround, which is basically disable the preview and detail panes in Windows Explorer, disable web client, disable ATMFD registry key, or rename atmfd.dll.
Yeah,
but they don't have any patches out. So
I think there's a zero patch for it, though. Like a micro patch. I think zero patch put out a micro patch for it.
Okay.
So to be fair, like there's something, but obviously you have to be, paid to zero patch.
Yeah. One thing that's interesting is they had a 7-day disclosure deadline, and the advisory was put out on the 23rd, and today is the 30th. So technically today is 7 days past the advisory date, but there's no additional information. Like you can see the last updated field on the page is the 27th. So we might see more like details come out about the issues themselves. Right now, it's very surface level. They just say 2 vulnerabilities. They don't say exactly what the issues are. They just say it improperly handles specially crafted fonts. So, like, we don't
might
have
see
too many
something
issues,
later.
We might see something today. Yeah, but at the time we're doing this podcast, there's not really too much to talk about there. So that's why our discussion is a bit more surface level. But yeah, if you're worried about these issues, you can do those workarounds or use the patch that you were talking about, the zero patch.
Use Windows 10.
Yeah, don't use Windows 7 because it's like 15 years old now or something. So but we'll let you guys do you. But yeah, no patch out right now, so just keep that in mind. So our next issue is in IBM's planning analytics software powered by TM1. So this software seems to be very old. It dates back to 1983. And it's used to process data from various sources and make it displayable in like graphs, Excel spreadsheets, stuff like that.
Yeah, well,
formats.
So it's an enterprise resource planning application, which is essentially you have throughout your enterprise a bunch of interconnected systems that'll produce data. This ties everything together, lets you query it from all the different sources, and produces, a nice spreadsheet, a graph, whatever. It's essentially there to help you query data from a bunch of different sources.
Yeah. So it has 2 major components, the admin server and the application servers. So these components communicate with each other through a REST API or a binary protocol. The binary protocol seems to be the default method that's set up at time of installation. The REST API seems to be like an optional thing you can use. And the application server seems to be the part that has the issue. And the issue is there's multiple methods in the protocol that you can call without being authenticated. And one of them is the process update from central function, which is used by specifying the message type hex 1AE. And it's used for like updating app data and server variables, updating configuration information from a central server.
Yeah, so it looks
And
like it actually supports a little bit more than that too. They do mention, so what they did find was that if you sent it, as you're kind of mentioning the layout of the binary protocol, one of the things that you can do is you basically give it a file name and a file. Like you tell it the file, and it's going to upload that file and
a
deal with
CFG
it.
file, yeah.
Well, so that's the thing. In particular, they found that if you provided the file name tm1s_delta.config, it would then go through all the things in that config file and replace all of the vars, so like environment variables and things like that. It would go through and replace them with whatever your new update was without needing any credentials. But it did also allow you to upload a file, and when you'd upload the file with a different name, it would mark it as executable. It wouldn't execute it. Like, it would delete it afterwards, but it did that, and that seems to hint to me that there's probably also some other sort of update mechanism, because it specifically, they only found this one specific method that worked, the tm1s delta config, but it supports arbitrary file names, and it does something with them. It does happen to delete them. So it seems to me like it's probably checking the name for something, or maybe checking the file for something also. So it might also do like an update, like a proper installer type update. At least that seems likely to me. So while in this case, how that one particular file is handled is by being able to overload basically all the configuration information. So as I mentioned, because of that, they also kind of found, because you can specify any file name, you could also do path traversal. So and this would actually prevent it from deleting whatever file you upload. Also, I was mentioning a little bit before that you'd upload a file, mark it as executable, and then it would delete it after the request ended. If you did path traversal, it wouldn't be in the proper directory, it wouldn't delete it.
I think it does still delete it, actually, but you can erase it. Because that's the attack strategy they propose. I want to double check that.
No, it does say here that luckily for the attacker, if we insert path traversal characters ... in the file name, the file will be written to other directories and it will not be deleted when the remote method terminates. Because one of their exploit methods they talk about is perhaps replacing, so this happens as root. So replacing etc shadow. And then just being able to log in like that. Or
so then why would it be a race condition if it doesn't get deleted?
They talked about several other... So first of all, without the path traversal, it would get deleted. So if you just uploaded it into the standard distributed updates directory, which is where it goes by default, it would be deleted, so you'd have to erase it. So if you have the path traversal, it doesn't get deleted, so it would be a race condition if you didn't do the path traversal. So if they fix that issue, you'd have to erase it.
Okay. I wish that was made a bit more clear, because I was under the impression that even if you did the path traversal, it was still deleted, and that's why you'd have to erase it if you overwrote etc shadow.
Well, I mean, to be honest, I'm not sure how much more clear it can be than it will not be deleted when the remote method terminates.
Yeah, but I mean, where it says the race condition with replacing shadow. Like, you're saying if you didn't use the path traversal, then it would be deleted. And that's why you need the race. But that path does not suggest that the path traversal is used. So that's why I'm confused.
That's actually weird. Yeah, no, that's a good point. I kind of saw that as being... it does mention the race condition described above. So I assume... Although that's the only time it mentions race. But I don't know. I kind of associated it with just referring to the fact that it gets deleted and like trying to execute that file somehow. But I could see why you'd see it as being relayed to the etc shadow attack.
Yeah.
Nonetheless, okay. I mean, we can move on from there. Essentially, if you do that, it doesn't get deleted, but so you could replace etc shadow or other important files using path traversal to overwrite any file. What they decided to do, though, was a little bit more of a stealthy attack or so, which is basically overwriting some of the config information. Now, I do say stealthy, but in reality, it wouldn't be all that stealthy. It does prevent some really obvious things from triggering, like some obvious alerts. But essentially, all they do is overwrite a few of the variables so that it uses a CAM authentication. And it uses, for the CAM server, it just uses an attacker-controlled address. So essentially, any authentication attempt that comes in, the attacker can just say, yep, that's the right authentication. I am absolutely an admin. And then once they have admin access, they can call one of the more privileged functions, process execute, and, execute code, plain and simple.
Yeah. It's a pretty cool issue. It's one of those multi-stage attacks that is, we love to see. I think it would have been cooler if they explored some other. Well, they didn't explore them, but they suggested some other methods you could take. One was overwriting some globals in the binary to plant security bugs, so you can cause like buffer overflows to get memory corruption. They said they didn't go that route. I think it would have been cooler if they explored that route or the SC Shadow stuff we were talking about earlier. But ultimately, I think the way they did it is also a lot more portable, and it's probably more stable. So it's not as cool. It loses some cool points, but it probably, in practicality, is a lot more stable and therefore better for an attacker to use. So
yeah, like I said,
you could hit it multiple ways.
Yeah, it seems like once you kind of have control of configuration, there's often a lot of things you could do. So, and since there's multiple issues here, there's multiple ways to go about it. Yeah. I will say it is a little bit loud changing the authentication. If somebody else tries to log in,
they'll probably notice.
Yeah.
Or look at it. Yeah. So yeah, the issue was reported on December 17th, but it was just made public on the 27th. So, just wanted to bring it up, and it is a cool issue.
Yeah, this was just the full disclosure of it, finally.
Yeah. After we're done the podcast, I may look into it a bit more to see with the SC Shadow stuff, to see if I can clear up a bit of my confusion around that. Because I'm genuinely curious. Maybe I'll add an addendum next episode when I figure it out or whatever. But yeah, we can move on to remote code execution in LNK files in Windows. So jumping into more Windows issues, we have a ZDI blog post about an RCE in Windows through LNK files. And what's cool about this post is it's one of those posts where they kind of go back and reverse a patch, like patch diff, to find the issue. They don't originally know about it seems. So
yeah, and this was actually out of February's Patch Tuesday, so it is a little bit old. The blog post is new, but the issue itself was patched back in February.
Yeah. So they note what makes LNK files so interesting for exploitation. And LNK files are basically shortcuts for people who aren't familiar with that term. It's a really good worm vector. It's been used to spread malware in the past. They even mention, I think, Stuxnet apparently used this, which I didn't know, actually. And it's apparently a really easy infection if you have local access, because all you need to do is browse to a folder containing that file. And then, Windows Explorer is going to end up parsing that file, and you end up, hitting the bug. And the issue doesn't seem to be an issue that ZDI knew about in advance, like I said. And these ones are always fun to cover because it offers some really neat insight, and you don't see it too often where you retroactively go back and, patch diff to find the technical details. So they started by looking at which DLLs had changed, and they found that none of the usual DLLs associated with parsing these files were changed, but one called structured query was. Which is apparently used for Windows search, and it bridges the gap between searching and shortcuts. And a little known feature of that bridge is the fact that searches can actually store search results inside of the shortcut files for future searches. So by patch diffing, they found a function that changed by about 20% on that Patch Tuesday patch, which was read prop variant.
Yeah, so, actually, just to jump in,
yep.
One of the things to kind of mention is it's not so much a bridge between shortcuts and search. It's more like a shortcut to the search. So if you do your search, you can save a search. So after you've done like your Windows search, you do all your things there, set up all your query parameters, whatever. It's like, oh, I need to go do something else. So you can save the search. That gets saved into an XML file. But if you were to like click and drag, which is a way of creating shortcuts, or well, I think it's like Alt or Control click and drag usually, but if you were to click and drag that search, you can get a shortcut created that is essentially a binary serialization of that XML file. So that's where kind of you get the link file, which happens to have some of these parsing issues that I imagine you're about to get into.
Yeah, well, the function gets very complex because the data structures involved get very complex. So they have like a huge section of like background information for all the technical details.
Yeah, they get very deep, like right into the weeds with this. The gist of this issue, though, is it's an uninitialized buffer that gets used as a pointer for a 4-byte or for a 4-byte write.
Yeah, essentially it seems to be like a type confusion. Most of the time it's expected that the type for the prop variants for what they call leaf conditions, which are basically search conditions, I think, they expect the type to be set to VT variant combined with VT vector. But if you don't set that VT vector type as well, the buffer is allocated, but it's not initialized like you were just saying. And one of the things you can do...
So what they plan, though, is that... So with the issue, you could have your prop variant has several types, and the vector is kind of a separate flag that indicates, like, hey, this is actually a series of this type, or of more props or whatever. So you can have like in a VT array, although that's not supported with structured query. But when it gets that VT variant and VT vector, if VT vector is not set, it's going to allocate, and it's going to call read prop again. It's expecting read prop to go and fill in that buffer for you. It's just as you're kind of getting towards there, if you start using another type, which is VTCF, which is clip. I don't recall what it stood for, but it's like clipboard. It's supposed to be a pointer to the clipboard information. But if you send it with that, the new type is VTCF instead of being what it expects. In gain of VT vectors and set for that new one, it's just going to go and use that buffer that wasn't initialized. It's going to take the address that's right at the start of that buffer and write the next 4 bytes that are in the file to that address. They don't talk about how they actually get the exploitation here. They don't actually show an exploitation case for how you can coerce that buffer to be filled with data that you control. They only go to showing
spray vector.
Yeah, I mean it really depends on what you're able to get, like how much control you have. Presumably you're able to get control because they do start zeroing the buffer, but they don't talk about that at all.
Yeah. So essentially what it boils down to is you can use an uninitialized read to get an arbitrary 4-byte write to any location because you can control that pointer. What kind of makes it interesting is, like you were saying, they didn't go too much into the exploitation details, but along with the getting control of the uninitialized contents, one of the other things I was thinking about is how do you deal with ASLR? Because you're going to want a valid good target to write to with that arbitrary write, and arbitrary write is very powerful, but it's not very useful if you don't have somewhere to write to, and that's where that ASLR defeat kind of comes into play. So I do wonder,
so because it's an uninitialized buffer, I imagine you can probably coerce a pointer into it. I imagine that would kind of be the way you'd go about it, is coerce a pointer into it, something that's kind of consistent that you at least can know of, or at least that you have like some sort of control, or you know what it's going to be pointing to. At least that's the exploit route that I can see.
That's probably what they did, but it does make it like harder for sure. Like,
yeah,
just something I was thinking about when I was reading it. But
so that's the thing with any of these sort of file exploits, like parser exploits, is ASLR does make them pretty hard to exploit, because you usually need to know pointer addresses when you're writing the exploit file itself.
Yeah. So the fix was very simple. It was just zero the allocated memory at time of allocation to eliminate the uninitialized read, basically. It's a fun bug because it's very complex and it's a subtle issue. Even though the fix is very simple, the issue is not simple. And, those data structures can get very complex. And how that uninitialized read comes to pass is, a series of just kind of very easy to miss things, you know what I mean? So yeah, it's worth noting this does give the same user rights as a local user. It's not gonna it's not gonna be too impactful if you're not running on an admin user or something, but it's still high impact because it can be exploited remotely, and it hits all three major impact metrics. It's gonna hit all, the CIA triangle. It took a bit of digging. I did actually end up finding the CVSS score, because the CVE didn't have like anything attached to it. It was reserved. They didn't have like the CVSS or anything attached to it, but I did end up finding it after a bunch of digging, for people who are curious at looking at that. Let me just get it. I thought I copied it, but I didn't. Okay, it's not copying. 1 second. My computer's being a pain today. There we go. So yeah, here's the CVSS score for anybody who's interested in that. It's a 7.5 basically. The attack complexity is high because of, like we were just talking about, it is a highly complex issue, but it is like hittable from the network, and like I said, it hits all CIA. So
yeah, I think it's hittable from the network, hits all the CIA. Does have user interaction required to do that network attack. You need somebody to browse to the network, share with it, plug in a thumb drive with it. It needs some user interaction for it. That definitely kind of limits how high the score will get.
yeah,
this is showing 6.7 on it, I think. Or sorry, 7.5. I was looking at the wrong area. I was looking at temporal. But if we had that as no user interaction, it's 8.1.
Yeah, it jumps
so like that makes a pretty significant difference in it. But like you mentioned, it's useful, especially with worming, just because of how easy it is to get the shortcut file to be parsed.
Mm-hmm. There were some other interesting points in their article as well, though. They stated that it's been a very big last few months for Microsoft for security fixes. I think they said in the patch Tuesday that fixed this issue, there were 99 CVE fixes shipped in that patch, which is crazy. So I thought that was kind of an interesting point that was worth highlighting. And another one that was worth highlighting that they said was there was another LNK issue that was patched this month, but it's a different issue from this. So maybe we'll see another write-up within the near future about the issue that was patched this month too. Or that could be like a fun exercise, diff the patch, try to find the issue. Yeah, basically do what they did. It could be like a very useful research endeavor, and could be a lot of fun. So maybe one of our listeners out there might want to do that. So yeah, if you want to look at LNK, there's another one for you. But yeah, those were just some interesting points. But ZDI articles, we always like to cover them because they are generally very good, and this one is no exception, though it is a bit less accessible than some of the other ones we've covered in the past, just because it does get really into the weeds on those data structures. So
yeah, I'm not sure if it's
to read into it
necessarily not as accessible or just really dry because of how deep it gets.
That might be a better description, yeah. So we'll move into some Pi-hole stuff. CVE 2020-8816, which is a remote code execution in Pi-hole, and it affects versions 4.3.2 and lower. And the issue is, it's basically just a logic bug due to a bad reg expression, which we've seen before. I think we even covered one last episode. And because of the regular expression being, less than apt, let's say, you can basically pass arbitrary characters for the first 12 characters.
It's actually like, if you look at the regex here, unfortunately our listeners won't be able to see it, but it's effectively gives the hex characters like square bracket and hex characters in there too, followed by an optional colon, and then requires 6 of them. That absolutely matches your standard MAC address, and it won't match a non-MAC address. Like, that's accurate. It's an accurate thing. It actually matches a valid MAC. The problem is, and this is something we have talked about before, is with regex, you need to match, if you're trying to do validation on it to like make sure it's valid input, you need to match the entire input. So like the last time I think we really talked about this in depth, the issue was being able to inject new lines, because people would use the caret character and the $sign to match start and end. And what that does, it matches the start and the end of a line. So as long as you get that match, then you can have everything on the next line that your injection does. In this case, preg matches, it returns 1. Like, they might have thought that was just the number of matches that it has. Or just, it was matching the entire thing because they didn't give it any further information. But essentially, it could match multiple max. It could match something else and not match something. As long as it matched it once. So the actual attack here was pretty straightforward in the sense of you give it something that matches the Mac, and then you have your entire injection after that. Although they did run into an interesting case here. And actually, I guess we should mention, so this is part of the web-based UI, like the admin UI. In particular, with DHCP, you can create leases on there to kind of like pin an IP address to a specific Mac. Fairly standard feature, so that's where this Mac is coming in there. So this is part of the admin panel. It is an authenticated user being able to inject into the code, or being able to inject code. The Mac is uppercase, and then it's used directly in the query sudo pi-hole -a add static DHCP, puts the Mac right in there, along with some other information.
Yeah. They did talk about how that STR to upper, converting
it
to uppercase did kind of cause issues that they had to work around to get code execution.
Yeah, almost feels like a CTF challenge with that one.
Yeah,
to get the code execution. Because all they and I mean, it was pretty straightforward. They used environment variables and characters that would exist in the environment variable, so they know that pi-hole is in the path, and that the path contains user, so they can get the characters like PHR, which gives them PHP-R, and then they can use uppercase characters in the actual PHP code that they're going to execute. So they use a little trick to get it. Definitely a fun little trick. Yeah, I mean, it's a straightforward issue there. I thought the regex aspect was probably the most interesting because just at a really quick glance, if you're just looking at the code,
it looks correct.
It looks all right, yeah. If you think about the code, it doesn't. Like, under what case does preg match return 1? And you realize that it will return 1 as long as it matched anything.
Yeah, and just to kind of highlight that, I did run the regular expression on like an online tester and just put a test string in there, which was actually like an example payload they gave. This was before they factored in the STR to upper, so it's not the actual payload. But I took a little screenshot of it here, so you can see people who are watching the video can see the regular expression there. It's set. It's exactly what they have, and it does match the first like 12 characters or whatever in the string. And because that matches, and it doesn't factor in anything else in the string, it's still it passes that check, but there's still that injection aspect. So I thought that was kind of that would be cool to bring up just to kind of give an illustration of the issue at work. But yeah, like you were saying, it's a pretty straightforward issue, and I like that kind of CTF aspect to it. That it was actually harder to exploit the issue than it was to find the issue itself, just because of that STR2 upper. So, CTF challenge, always fun.
Yeah, and I guess I will mention, since I did mention sudo being used there, just to be clear, this is only running as the local user, because you basically do like ampersand to start up a new command, so sudo doesn't end up applying to it. Just in case anybody was listening and thinking that this might be running as root, it is a local user. It is in the admin panel, so they're authenticated. This is going to be rare to see in the wild. I believe the author actually did a showdown query. He doesn't mention here. He mentions it in his Reddit post, though, of several hundred exposed admin pages. So it's not a ton, but they are out there that do expose the admin panels to the internet, which generally speaking wouldn't be recommended. Ignoring the authentication aspect also. You do need to have the password. So your risk here is low. Yeah. It's still an interesting issue. Like, it's still an issue. I mean, if you had the same thing in pfSense, you'd still report it because somebody who has access to the admin panel shouldn't be able to also run code necessarily. Like, it's still a privilege escalation.
I did want to point out, I looked through the source and I found the fix. Basically, the way they fixed this was instead of using their own regular expression, they just use filter bar and use the validate Mac filter.
They use what's built in to PHP, which is
what you should always do. Yeah, because somebody's probably done it better for that kind of stuff if it's built into the language. The other thing I did want to point out, though, is if you look at this code, I found this code to be like really terrible and like a massive red flag. If we go down to like the lines where you actually find the issue in like 565 and lower, you'll notice they do like this weird error checking where they set an error string, but they don't bail out. So they basically check the length of the error string anywhere before they do anything, which is like super easy to miss a check like that. It's super easy to like not handle an error by accident. Like, I think there's probably a lot of issues in this code that, could be found because it just looks bad. It's kind of a red flag for me. I don't know about you, Z.
Well, so I'll say that is kind of a common pattern in PHP. So maybe not the string length of an error, if that's what you're seeing. I'm not seeing where you're getting that if it checks the string length of there. I just see it appending to the error every time.
It's at the bottom at line 611. They have if not strlen error and stuff like that before they execute the command.
Seen, yeah. That is a common pattern actually in PHP.
Yeah,
whether or not it should be is a different question. I
think it's very easy to like have bugs.
It's easy to forget to do that sort of check.
Yeah, that's my issue with it, I think.
But at the same time, like what they want is to be able to handle kind of the errors. Like they get all the error messages and then they can just pass that back out instead of executing.
Yeah.
Like they want to run all the errors so they can give you a complete error message. Because that's effectively what it is. It's doing all the error checks here. And then it's saying, and if there was an error, it just happens to be that they're using the string length to check the error. But I mean, you could think of that as just being an error flag too. And if there was an error, it's just going to leave. It's not going to actually do it.
I guess I'm just used to where in C you handle an error right away and then bail out. You don't keep executing when you have a critical error or anything like that. But I can see why they do here. Like you're saying, they want to get all the errors. But I think that style is like...
It's common with PHP. It's common actually in a lot of the web languages just because you kind of... It makes for a nicer UI experience when you're able to give all of the errors and stuff like... you fix your one error. Oh, and this was also a problem, so you submit. Oh, this was also a problem, so you submit. This is one way of dealing with that, by doing all the checks and then checking if the error existed. I could get why you could miss that. At the same time, like I said, because it is a pattern that's used, it's somewhat expected also.
Yeah, okay. All right, fair enough. So our last exploit topic of the day is a NordVPN, and it's not really technical. It's not technical at all, actually. It's got more of like a social engineering side to it, but it's basically using the support functionality to request an account deletion on behalf of someone else. Now, what's important to note is they do actually verify the information before deleting the account if the account is activated, and it seems the account that this person tested with was not activated on registration, which is why they deleted it without question.
Let's say what the issue, like, you kind of touched on the issue, but just to mention, with the support form, when you're able to create a ticket, you're able to specify what your email is. So what email they should respond to. So you send a thing like, hey, delete my account, and you just write in the email of somebody else. That's... I guess the picture isn't going to load, but that's the gist of it. You send a support email, ask them to delete, and you pretend you're somebody else. More or less, like, you can understand, like, it's a social engineering thing. You could see where that's coming from. As Spectre was just mentioning, in terms of verification, if the account has payment information, they'll ask you it. They'll ask you for some of that information so they can verify you're the account owner. In particular, it's payment information because that's all the information they collect about the user. So, in this case, this user happened to test it using an account that didn't actually have like a VPN, like they hadn't paid for a VPN yet. So they had no way to verify who the owner was, and they just, of course, they could have, sent a validation email. There are things they could have done. But in this case, they didn't. They just deleted the account. So it seems like, and the title is unauthorized user can delete any user account. Sounds like a serious issue.
Yeah. I think she did bring up a point that's kind of fair, is that, NordVPN should make it more clear that they are going to do like a verification process like that on those kinds of actions. But then again, like...
Well, you would just experience it. Like, it doesn't...
Yeah, it's not really that important.
If you're having to submit a ticket... Like, I mean, whether or not they do the verification, you're expecting there to be some level of human interaction to it. Like, they have to read the message to go and delete it.
Yeah. Like,
you're expecting that. So, I mean, I think it's just kind of implied that there's a process. Whether or not it's a process of them doing the verifications different, but, all they mention is it should be... and I do actually agree. Like, I think it would be better if they just had like a button you can click to delete your account, not needing to go through support.
Yeah.
But I can understand them doing the support so that they can also do that additional verification. And just in this case, they happened to basically not have a way to verify the account. That said, they did pay out $100 bounty on this.
I was surprised at that. Yeah.
Yeah, well, so I don't quite get why. They still left it as a non-issue, basically. Like, they didn't somehow decide it was more issue. They just said another report was submitted to us more recently that they rewarded. I wish they kind of had information about why they
There's no issue
the other
here.
one.
It's weird. Yeah.
Well, I could understand somebody saying there's an issue, but they don't make that clear. That's kind of where I'm coming at. Like, they don't make it clear what they thought the issue was. Like, I guess privacy violation is, they changed it. Like, they added the privacy violation, removed the privilege escalation. Like, I could totally see this being called an issue. That's fair. It's just, I don't know. In this case, you're left with, somebody else did it and we paid them, so we're going to pay you too. I don't know. It just felt weird to me.
Yeah. I think what this, report highlights is if you're going to be doing bug bounties and stuff like that, you need to double check things. Before reporting this issue, ideally, you would have activated the test account to make sure that, you would have caught that issue. So, I don't know. It just kind of highlights that fact that you got to be thorough, I guess.
Although, I mean, at the same time, you expect an account deletion to more or less work the same for everybody. Like, I can understand them expecting something to exist that wasn't just deleting the account all because they didn't actually pay money.
Yeah. I think the best way they could have handled it is they could have at least made it so if you submit a ticket request like that, account deletion is ultimately left to the user to do. Like, they send an email with a clickable link that's like, click this link to deactivate your account if you're really sure. And then if you didn't have access to that email, then, even if you did this kind of attack, you're not going to be able to complete it, right? The person's going to see the email and they're like, oh, I don't want to delete my account. And then they're just going to ignore it. You know what I mean?
Yeah, and email verification would be a really easy way to confirm.
Yeah.
Although, yeah, I guess they would have to have your email. I was going to say, because they do mention they only track the payment information, but I guess to log in, you do need to provide an email. Although, if you lose access to your email, you'd still want to be able to delete your account.
That's a fair point, I guess.
But you could open up a ticket, go through another validation. I mean, that's easily solved.
Yeah. So, it's not really like I wouldn't say it's an impactful issue. There's like no impact, but it's informative. So, just wanted to bring it up because I think this is like a highlight of that point of.
Yeah, well, I initially added it, just based on the title alone. Unauthorized user can delete any user account. That's absolutely.
Yeah. So we'll move into some research stuff. Our first research touches back on what we were talking about earlier. We said we were going to talk about something that dealt with SGX a little bit, and this is it. It's smart contracts in SGX secure enclaves. And it doesn't really talk about any concrete issues, but it talks about some theoretical attacks that you can pull off. And it's basically a collection of observations of bug classes they found in smart contracts that were implemented or could be implemented in secure enclaves. So one thing that I think is worth noting before getting into the issue specifically is with smart contract systems, even if they're using secure enclaves, the contract data is stored in an encrypted database that's not in the secure enclave. And the reason for that is secure enclave resources are very limited, especially when it comes to memory. So they can't really afford to put that data inside the secure enclave. And that bridge of where the encrypted database is not on the secure enclave, but the contract is where a lot of the issues kind of pop up, is that you can basically side channel that. Almost all of the attacks they propose are side channels. And the first attack deals with rogue smart contract injection. The output is encrypted of the contract, so even if you can run any arbitrary contract, you can't get the output without the keys to decrypt it. But there's the potential for an attacker to establish side channels within the contract through things like timing and ciphertext leaks and stuff like that. That can allow them to leak information from the smart contract that's running. So that's the first issue. The second attack focuses on that ciphertext leak aspect itself, and the fact that the state is tracked outside of the enclave. So they can basically compare the state before the contract is ran and after the contract is ran, and kind of backtrace to try to find secrets based on like the delta of the state. There's a few other attacks, like the third one is for potential for timing attacks, like we already kind of said. Even if you don't control the smart contract going in, you can kind of do timing attacks on how long that contract takes to execute. The fourth is similar to the third, but it extends to opcodes and memory access patterns. So basically all of them are all like side channels. And like some of the other ones they mentioned are basically along the same
I will mention
vein.
the first one actually isn't a side channel, the injecting smart contract code.
But it is establishing a side channel. So it's kind of similar. So.
Well, so that's more because the only way... So because the actual store and load operations are encrypted by the VM, like because that happens, like there is no way to easily get out. So you do need to use a side channel. But the actual attack is just, somebody who's got control of the machine that the VM's running on, that the contract's running on, they would be able to feed bad code to the trusted execution environment. So that's the attack. Now, yes, you can then use that bad code to introduce side channels, but the attack is just the code injection, is the fact that somebody who runs the system would be able to do that unless you have some way of validating it. They actually mentioned giving the contract a mean to validate the code applied to a given address is correct by using the location as being the hash of the code itself. And it sounds like that's just a suggested EVM improvement. It's not something, because you couldn't really do that without having it built in at a higher level. Because if it's in the code that you're running, that you're providing to validate that's correct, the attacker can control that too.
Yeah, that's a fair point.
But yeah, so that's one of them that isn't a side channel. The rest are, as you mentioned, largely side channels, getting information, as you mentioned, the timing, the VM itself leaking information. Obviously, we've talked a ton about SGX side channels before.
Yep.
One of the other attacks that they did mention, or two of them actually, that aren't really, or that are less about side channels, are cross-contract calls. So if they're both confidential contracts and non-confidential contracts, if you can control an argument to the non-confidential one, you might be able to leak information that is confidential through the arguments that go to the non-confidential one. So that was one of them. And the other one was tampering with the contract state. While there's crypto and it's authenticated, ideally it's authenticated, so you can't actually tamper with it, you might be able to replace values outright. So take a value from one issue that it should be signed, it should be authenticated, and just swap it right in with another one and be able to make modifications that way.
Kind of like a replay attack. In a way.
I mean, yeah, in a sense, you're reusing the data, but you're not really replaying a request. You're just taking the results that already exist. You're taking an existing, perhaps something that you control the data for, and you're just plopping it in place of other pieces of data.
Yeah.
I mean, I could see where you're coming from with the replay idea. Like, you're replaying, you've got the data that was previously used, and you're reusing it. Like, I could see that. I would definitely make it distinct from a replay attack, though.
Oh, yeah. I'd agree with that.
But yeah, I mean, this was just like, I mean, I've said it, or at least I've probably said it on stream. Like, I have a ton of respect for NCC Group, and I love their team. Like, I've basically never met anybody from there that I couldn't respect. So I like seeing their research come out. They've done a few things, like there's just overviews of issues that they're running into in the real world. And this is one of those. Like, none of these are new issues. That said, it is an area that I think a lot of people just aren't really aware of, aren't really thinking of the issues with smart contracts yet. So just laying it out, like, these are some things when you're developing a smart contract, you need to be aware of the side channels. You need to be aware of how some of this information can be pulled out. So I thought it was worth kind of covering here.
Yeah, they are theoretical. There's no like concrete attacks. Like, you can absolutely use this type of attack against this system. There's nothing like that.
Well,
but it's stuff that's worth considering.
I wouldn't. I wouldn't call this just theoretical. That's like calling a paper about cross-site scripting in general theoretical. Like, they're real attacks. Like, just they don't give you the concrete case where they saw it, but they are real attacks.
Okay, yeah, theoretical isn't the right word.
Yeah, yes. Like, I feel like theoretical just dismisses it a little bit too much.
That's fair. Yeah, but they're just not like attacks that, you're just going to go out and use. But they're things that you should keep in mind if you're, working with a smart contract. Well, you could
if you're going to attack smart contracts.
Perhaps, but, maybe the smart
level
contract
facts,
system...
Like,
the reason I'm saying it's theoretical is you can take one of these attacks and try it on a smart contract system, and maybe it's wise to it. It's not guaranteed to work against any given system. That's why I'm saying it's something that's worth keeping in mind, but it's not necessarily something that you're going to run into in the exact system you're looking at. You know what I mean?
I feel like maybe we can get onto a side discussion here, but you could say the same thing about cross-site scripting, SQL injection, buffer overflows. They're all just theoretical attacks then. Like, I know where you're getting the theoretical, I just feel like it's dismissing it too much. Because in this case, every attack's theoretical then. Going by that, because it's not shown with a concrete case. Everything can have defenses against the attack. Unless you've got some attack that just works everywhere, like, truck through the wall in a server data center.
That'd be a pretty cool attack.
Well, so there are actually mitigations against that, the bollards and stuff outside, placement of the data center.
I actually didn't know that. But
yeah,
makes sense,
so there are defenses against that. Nonetheless, I feel like saying it's theoretical. Like, it's an attack. It's just an attack, like cross-site scripting or anything else would be.
Yeah, fair enough. Yeah. I did want to highlight one thing I thought that was kind of cool, is that if you scroll down, they actually provide like an example, simple smart contract and point out like some of the issues that they kind of highlight up above and how they can occur in that. I didn't look too much into it, but I thought that was kind of neat that they provided that example for anybody who's interested. So, they've got that there if you want to understand the issues a little bit more.
Yeah, and I guess for what it's worth also, I will just mention that there is actually a online, I think I've actually brought this up before. There is a blockchain CTF that does have some blockchain challenges that you can try.
Yeah, I think you mentioned
I brought it up. I must have brought it up in like one of our first episodes though, so I figured I'll bring it up again. It exists. Like, it's something to play around with some common issues in blockchains.
Yeah.
So the link will be in the description, but for those listening, blockchain-ctf.securityinnovation.com. And it's literally just that. It's a little CTF with the blockchain. I think I need to have MetaMask installed to actually pull up the page I was just trying to view, but yeah, I mean, it's something to play around with. I think smart contracts are definitely, we're seeing them used a little bit more, so it's worth being aware of some of these issues.
It's an area that's pretty different too. Like there's some unique bug classes in it that you won't find anywhere else.
Yeah,
And I
well,
think
it
that's what's
has.
like really cool about it.
It's a unique environment, yeah, and because
Yeah.
of that, unique issues.
Yeah. And one thing that is worth pointing out is obviously earlier we were talking about the fact that SGX may be dying. And while this paper does focus a little bit on SGX, I don't think it's exclusive to SGX because these issues could exist probably with any trusted execution environment.
No, and they mention that it's running smart contracts in a trusted execution environment, such as SGX. So while
Yeah.
they talk about SGX because that's your most common one, it's it's open. Like anything that's a trusted execution environment, in theory, can have these same side channels.
Yeah. I do just want to call out real quick. Thank you, JDogHS, for the Twitch Prime subscription. We really appreciate it.
Thank you.
But yeah, we can move into the next research topic,
Well,
which is
before
from
we go
Microsoft.
there, I do actually
okay.
want to deal with chat too, really quickly.
Okay.
That was Cat 3009 again asked, can I ask what you guys or what you do? Basically, we're unemployed bums who do this.
Day zero was our job.
So I mean, we don't need. I don't know how much information Spectre wants to give out about himself. I've worked in the security industry for the better part of the last 10 years. I've done application security, doing like application level penetration testing or just assessments at the app level. I'm not a big fan of calling it pen testing because when it's application specific, it's more like a vulnerability research, that sort of assessment. I've done that for a while, and I worked as a game dev before that. And then like a magician, and I was in the military for a couple other random things to toss in.
You've done like jack of all trades. You've done it all.
I've bounced
Most interesting
around
man
a bit.
in the world. Yeah. I don't have any professional experience, I guess. Like I haven't worked in the industry in like a pen testing firm or anything like that.
No, but you've definitely done independent research.
Yeah, I've done independent stuff. I've done like I do like bug bounties and stuff of that nature. But that's where like Z is able to go into some of the. I think he's able to be more charitable to companies and stuff like that and give some of that unique insight where I haven't been in that environment. So that is one thing that's like that's cool that like we have the two different areas so that there's the different angles of looking at stuff. So basically what I'm saying is I have an excuse to never work at a pen testing firm because I want to offer unique angles. Use that as an excuse. But yeah, we have some different backgrounds, but Z definitely has more of a professional background than I do in terms of like working at firms and stuff like that. So yeah, we will jump back into the research topic though of Microsoft, and it's about hardening control flow integrity through hardware-based stack protection. So Windows 10 has had control flow guard for a while, and CFG basically tries to protect indirect calls, what's basically called forward edge CFI. And basically how that works is, when a function is called or it goes to follow it, the address is checked against a bitmap, which is protected by Hyper-V. In Windows case, it's protected by the hypervisor. So if you pull off something like a use after free and you overwrite a function pointer, you'd have to use a function pointer that's in the bitmap. And that makes ROP very difficult, if not impossible, if there's not a good function for you to call, if that jump is protected by CFI. And they're looking to extend that further to have hardware force protection to protect return addresses on the stack as well through shadow stacks, which is called backward edge CFI. So this is going to be done through Intel's Control Flow Enforcement Technology, CET, which I think we've talked about before. We might have even talked about it as recently as last episode.
Yeah, we've talked about CET a few times, or at least implicitly. Last episode, we definitely talked about it. If you're not familiar, basically, there's some of these things that are actually being implemented at the hardware level now. In particular, now with the shadow stack, Intel, if you've got CET on your CPUs, then it will include an increment shadow stack pointer, read shadow stack pointer, save shadow stack pointer, and restore shadow stack pointer as instructions that you can use that will be enforcing the shadow stack effect that you can use to implement the shadow stack. So this is basically hardware level enforcement of the shadow stack. And that's it. Just while we're talking about that, there is a really good post on Windows internals that it dives, and this was actually back in January, that dives into a lot more information about how it's actually implemented and works, among other things. Like there's just a ton of Windows internals details. I mean, this is a post by INSQ, I think.
Yeah, I was about
Yeah,
to ask, is this the same people that do the
yeah,
Windows internals books? But if it's INSQ, then yeah, it's the
yeah,
same.
yeah.
Same guys.
Well, yeah, it's their blog.
Okay. Okay.
It's the internals blog. So yeah, it's got a lot of details about that. Perhaps some issue points also are kind of raised within it. But yeah, if you want more information, that'll be in the description.
Yeah. It's one step up from stack cookies, basically, because it should protect basically all return addresses with the shadow stack, whereas cookies, it's possible that the compiler forgets to put a cookie in some function, or it thinks that it shouldn't have a cookie when it should.
Yeah, well, cookies are definitely used selectively, whereas this should be used a lot more. That said, there are cases where you do need to be able to modify the shadow stack. Like exception handling can cause it to return off a bit without actually returning, for example, to unwind it a bit.
Yeah,
so, like, there are going to be certain gadgets that you might be able to use to get around this too.
Yeah.
Just something to keep in mind. I've glanced over the Windows internal thing. I have not fully read it. It goes into a ton of detail. It's a fairly long read. So I haven't gone through all of it myself. So, I mean, I haven't spent a lot of time thinking about how to break this particular thing. But what I imagine is going to happen is similar to like DEP and ASLR. They came in and, there was concern, but eventually, techniques were found around it. Edge cases were found that weren't protected or that could be abused.
It's worth mentioning that neither Z or I do much Windows stuff, so we haven't personally had to bypass CFI. So, but it is we are seeing shadow stack technologies coming into things like Linux, or at least being researched and potentially coming to Linux in the future. So I mean, part of the reason you see there's kind of this focus on doing it, even though we already have stack cookies, is not only is it used pretty much everywhere. The reason it's used pretty much everywhere is it should be lower overhead, I believe. I'm not entirely certain, but it should be lower overhead because it is backed by hardware. So, stack cookies and stuff like that, those are all purely software. A cookie is put on the stack, and then at time of return, before it returns, it'll check that cookie value has remained intact. Whereas this is all being done at the hardware level, so it should be less overhead. Now, they do have this...
Sorry, there's one question of chat. How did MS support it without such CPUs on the market? So there's actually the microcode has been patched on older CPUs to basically treat these instructions as an op. So that allows them to be implemented, and then when the CPU sees it, it'll just NOP.
Yeah. So you can opt into this if you're already on Windows Insider builds. They've added a linker flag to Visual Studio called CET-compat to enable it in applications. It sounds interesting. I think this post was pretty cool, but what I do question is how many people are actually going to use this, because they state it's an opt-in model. And
opt-in for now. So they don't actually say for now, but that's my thought, is that they've made this an opt-in feature. They say by making this an opt-in feature, developers can first validate and test their app. I don't know, it makes me think that this might change. Like, if this were to get adopted a little bit more, they may make it an opt-out. But obviously, when they're first introducing something, they're not going to make it an opt-out.
Yeah. I mean, it's just one of those things where, one thing we've learned through security over the years is if you have a security feature as opt-in, it's almost certainly not going to get used. So, it will be interesting to see if it does eventually phase, like you're saying, into an opt-out model. If it, works out and it works for applications that it's used on and stuff like that. That is an interesting point that you brought up that I never even thought of, actually, though, is the stack unwinding for exceptions. I could see that being something that maybe needs to be worked on before this becomes an opt-out. I don't know. I don't think they talked about that much
so I
in
think,
actually.
They'll probably discover more edge cases, too. And actually, to be fair, that's a point that's mentioned in the Windows internals blog, is the unwinding and stuff as being kind of like these edge cases, and they're probably going to find more and more edge cases and things that need to be supported. before they can make this something that's just mandatory. And the other thing is CET is Intel only.
Yeah, that's another good point that I was thinking about when I was reading it, but I forgot to write it in my notes. Yeah, it is Intel, so with people on AMD, you can't force it on them. So, well, you could have the CET compatible flat. Yeah, no, never mind. I was gonna try to say be charitable and say maybe you could make it work, but
I mean, I wouldn't be surprised if AMD start putting out something, or maybe they're already working on it too, like something similar. So, I mean, there's that opportunity too. Or this could just be something Intel only does. Or AMD has their own implementation.
Yeah, we'll have to keep a lookout and see if, this becomes like an opt-out and becomes the standard within a few years.
Yeah, and I guess something I forgot to mention actually is, obviously this, you were mentioning the CFI for forward edge stuff, so all the kind of forward calls, whereas this is backward edge. There is JOP too as a valid technique here that could be used. You could probably do COP too, so like jump-oriented programming, call-oriented programming is an option besides return-oriented programming. So you could use that. Like that would also get you around the shadow stack as long as that would be protected by the forward edge.
Yeah.
As long as the forward edge though is being opted into, and we've talked about other forward edge things that are only kind of partially doing it. That have issues with how they're being implemented. We definitely don't have very strong forward edge protection as a default at this point, or at all as a default, but
doing the heuristics is hard.
Yeah, like finding out what's going to be valid or not. So you end up having a lot of gadgets that can still be used, or just software that doesn't work. Either you need to have the heuristics, you need to have some way of determining it, or it ends up being too general to be used. Like there's the whole CFI with counterfeit objects oriented programming, the co-op attack. I think we've talked about that quite a while back, which is against vtables in C++, essentially being able to defeat most CFI implementations because they don't take into account all the indirection that natively exists in C++ code, just in their objects and stuff. So there's CFI still needs work, so I think JOP isn't going anywhere just because there is the CFI. There's still usually gadgets you can find that can be used. Still limited. You might be limited somewhat in terms of what you can call, but JOP's still going to be a thing even after ShadowStack comes in. But ShadowStack does do, I think, a much stronger job against the return-oriented.
Yeah. So our last topic is a little bit old. It's from February 5th, but it's another, mitigation, and it is fairly important for Linux kernel stuff. And I think we did miss it, so, we still wanted to talk about it.
Yeah, well, so I definitely don't watch the kernel mailing list.
I probably should, but I don't either.
Yeah, so, I mean, missed it there. That's what brought to my attention was somebody actually tried to defeat the random number generator used for this. I think we'll end up touching on that, but fine-grained ASLR in the Linux kernel is essentially, this is a patch suggested for doing that, which is effectively, normally with ASLR, you kind of have your entire module that are, or you have your entire module, and that gets loaded at, say 0x1000. And with ASLR, maybe they'll get loaded at 0x5000 or 2000. But it won't be loaded at 0x 5256. It won't be, or I guess the better way to put it actually would be, it's loading the entire module just offset. It's not loading the individual functions in different places, which is what this is talking about doing. Loading every function at a different location, randomizing the entire thing. So when you leak a pointer, rather than just being able to calculate, okay, this pointer points to this thing, so offset from that, I know where, everything else is. Now it's going to be okay, so I know where all this function is, but I don't know what function comes next. I don't know where anything else is loaded. So that's kind of the gist of what this is trying to implement. I did think it was interesting. This is a GCC thing. We've talked about other mitigations that they've looked at implementing that have been Clang, whereas this one is specifically GCC, which I just thought was interesting to see a little bit of the security push on there.
And another point is, I thought the Linux kernel, maybe it was just the Android kernel, but I thought the Linux kernel was trying to move away from GCC as a toolchain. I thought they were trying to move to using Clang. So it is interesting to see the mitigation introduced in that as well, just because of that. So,
yeah,
that's kind of weird.
Yeah, it's just something that I noticed. And I mean, you can kind of give the mailing thread a read if you're interested in some of the details. I had mentioned, though, that so obviously if you're randomizing it, you have a random number generator somewhere. You need to be able to generate random numbers with sufficient entropy to move the functions around. You don't want that to be predictable. Now, in all fairness here, this is a proof of concept. It's mentioned as a proof of concept. It's mentioned that the PRNG is not a secure one. It's just, here's a proof of concept. But what I thought was funny was one of the comments in here was basically, they mentioned that this might improve shuffling speed at boot only marginally in terms of the PRNG being kind of like this custom thing. Comment there being, don't do this. Use a real.
Don't do this.
Someone is going to break the construction in your patch just to prove they can. Which is actually what brought my attention to this patch in general, was that somebody went and did exactly that. They went ahead and, tried to break the RNG here. And I'm not going to walk through it, gets into all the math and everything about how everything's working. But that's effectively what happened, is somebody went to break it because they could.
Yeah. So I think the idea overall is it's pretty significant. I think it will, if it does end up entering the Linux kernel, which I think it will at some point, it will kind of bring about a new era for mitigations. It is like it's going to make exploitation harder, just because you're likely going to need another bug to chain on top of the ASLR defeat. Not only are you going to need
you're going to want you're going to need almost like an arbitrary read.
Yeah, you would need to
like
do
you
live,
can do
function searching with an arbitrary read. You need to basically egg hunt for all of your gadgets that you want to use. So it will definitely make it more challenging. You can get around it, like we're saying, with the arbitrary read. When you're talking about kernel, overhead is important. And it seems this mitigation doesn't introduce a ton of overhead. It says 1 additional second at boot time and roughly 1% added overhead at runtime. That being said, I don't know how much I trust those numbers. Just because in the kernel, you do have a lot of indirection. You have a lot of function tables and function pointers and stuff like that, because it's written almost to be like object-oriented in a way, as object-oriented as C can be. So I think depending on paths taken, which syscalls are called, stuff like that, I think the overhead will be a lot more drastic than maybe they're initially thinking. So
perhaps,
I think the overhead will be higher than they think.
I mean, you've already got, the what would be like a symbol table lookups. It's not necessarily like we've already got that in userland. Not userland randomization, but it's already doing the lookup there for resolving symbols when they're in like dynamically load libraries and stuff, and that's not adding all that much overhead.
But those are only resolved once, right? Well,
you only need to resolve these once, though. Yeah. I mean, the kernel's just going to be once. It's randomized on boot, so it adds that second early on when it does that randomization, which presumably would vary depending on how fast your CPU is. I feel like the second is maybe the wrong metric to use there, but essentially it's not terribly long being added.
Yeah, I guess that's a fair point. I don't think we'll see this in the Linux kernel for a while, though. I think it's going to need to be tested very thoroughly before it even comes close to the mainline kernel or as a default configuration option. I think we might see this within a few years, though. I don't know what your thoughts are on that.
No, I'd agree. I mean, it's something I don't see why you couldn't do something similar in Clang. Because essentially it just splits out all the functions into their own segment, or into their own sections. I believe you can do something similar with Clang, might not be implemented for like as automated as is with GCC. But as things are moving towards Clang, like I could see this coming there too. Like I don't see a strong reason why this couldn't be applied.
It does require a significant amount of work in the dynamic linker, though, right? To handle all those cases. That's why I'm thinking, like, it's going to need like a lot of testing to make sure it doesn't break stuff. We know how Linus is with patches breaking stuff. So yeah, that's why I think it will be a while, but I think we'll see it. One thing that I think is worth noting here too, if this does end up coming to pass and we do see it in the kernel, not only is it going to add that added complexity of exploiting it because you need to, find your gadgets at runtime using something like an arbitrary read, it will also probably kill portability too. Because even if you search for functions or gadgets at runtime, for functions specifically, you will need good search patterns, and those could end up breaking between kernel versions. Or with gadgets, you could end up having gadgets in certain kernel versions that don't exist in other kernel versions. So it could end up breaking portability too. So
yeah, although a lot of the gadgets are going to be within kind of a specific function that does something. So I don't think you're going to see all that much breaking just because the functions are being randomized.
Probably not.
Because, especially a lot of gadgets are, ending on the return anyhow. Assuming you're doing like ROP style. I don't know. I don't think this randomization is really going to break too many gadgets.
It could be more harmful for JOP than ROP, to be honest. Because JOP is one of those things where there is a bit
you might run over a return.
Yeah, like, there is potentially more issues there, but yeah.
Although, I don't know, so I haven't done a ton of JOP, but I can't think of too many gadgets that I've used that actually have been, like, that have run over the return. They've still been contained within a single function, essentially. Just a little bit of code before a jump, or like before getting me back to the dispatcher.
Well, part of the problem that I was thinking of with JOP is that the gadgets are a lot less consistent between versions.
Okay, yeah, well, I'm kind of getting more at the randomization isn't what's breaking the gadgets. Versions can still be breaking gadgets. That's going to happen just as code compiles differently or whatever. I just don't see the randomization as being
could end up
the cause.
That randomization could end up breaking the jumps as well, but yeah, I don't know. Well, because the relative jumps are going to have to all be relinked. So I don't know.
We'll see how it plays out.
We'll have to see. We'll have to see how it plays out. It's tough to think about because especially when you're talking about things in the Linux kernel, there's so many like different possibilities, and that's why I think it's going to be a while before we see this for sure. But we will end up seeing it almost certainly. But I think that pretty much sums up that topic. Before we exit, though, I know you have a shout out, Z?
Yeah, I saw this actually on Reddit, Slayer Labs. I know we get some people coming in from looking for things like OSCP, OSC, and stuff like the courses. Slayer Labs, I think, kind of looks interesting. So first of all, this is only to the Americans in the audience. So I haven't been able to test it as a Canadian, unfortunately. But essentially, it's a vulnerable network. So kind of like a CTF, except it's a full network that you can explore. Multiple vulnerable machines, multiple ways to kind of pivot through the network, make your way through. And what they've done is they've released this. You can get access to it for free for the next few weeks due to the coronavirus stuff. They're just putting it out there. You do have to email them to get access. But it's their Roadhouse cyber range. Oh no, I just thought it looked interesting, so I did want to kind of mention it's there. They're offering it for free for right now. Like I said, sign up does seem to be a pain, but I do think it's interesting.
Why were you saying it was only for the US? Do they?
They only, that's their limitation. Only US. Yeah. US only, not behind a proxy.
Folk, man.
Yeah, and I don't get why that's their issue. Because they mentioned that it's in the Reddit thread. Which is, like I mentioned, I first saw this on Reddit. They make the mention that a few caveats. That's US slots only, you need to agree to the terms of service. And they mentioned that... Okay, maybe it was on here, maybe it was in their FAQ. Either way, what they do mention that... It's for time zone reasons, but then I don't see why Canadians and Central Americans wouldn't be able to get on there too. Because they take down the servers apparently for whatever reason during it. Yeah, well, so availability too, out of chat. Mentions due to availability. I thought I read something about that too. Yeah, so I think what they do is they mention, must have been the FAQ then, to mitigate potential connectivity issues and daily off-hours maintenance. I don't know. Connectivity feels like a cop-out. Again, like Canada's going to be just fine connecting to the US, for example. And daily off-hours maintenance, well, if you're in the same US time zones, that's not the issue. So I don't see why they're keeping it US only. It sucks that they are. I mean, and the price is, like, even though it's free right now, it's $34 for 30 days of access. This is a network similar to like an OSCP network. So if you're doing OSCP, this is the sort of thing. It's not exploit development or manual buffer overflows. They do mention that here. So it is more like what you might run to during a network pen test. Which is definitely valuable because a lot of war games you see online are those CTF standalone challenges. This is a little bit more real world, something more you can look at and kind of pivot around, do that. The few dollars for a month of access, $34 a month of access, that's pretty cheap compared to getting like an OSCP lab extension. It sounded like you were going to say something, Spectre?
Yeah, I was just going to say, I found it interesting. You can also just buy it for 2 weeks if you wanted to, too, for $20.
Yeah.
Like, off when it's not free, obviously. So yeah, that's kind of cool that they offer like that 2-week option, that cheaper option. I wanted to point out too, I found it funny that Reddit thread you brought up was actually originally, like, the original post was a VPN to use it, and it got removed. So I noticed that really quickly while you had it open.
Sorry, so the original post was what?
The original post was I think a VPN so that you could connect into this without being a US citizen or like living in the US.
Oh, no. So you get access to it through, like, this is a network that you connect to over a VPN. They mentioned...
Oh, okay. So why was the post removed?
Oh, the post was removed because it's marketing. NetSec doesn't let you...
I thought it was removed because it was bypassing their, like,
no, it's reject as marketing reasons. Okay, that said, I just have the NetSec feed, so I see it even if it is removed.
Yeah, fair enough. I noticed that, and I thought that's why that was like that. So okay, fair point.
But yeah, I do think it's interesting. I don't think there are a lot of other systems like this, because even Hack the Box is usually just a single box kind of boot to root type system. Mm-hmm. So this is, yeah, I mean, especially at the price, you could learn a lot playing around in an environment like this.
Can't beat free, really. So,
yeah,
definitely worth checking
if you're in the US right now.
Yeah. But that does pretty much sum up all the topics we have for this episode. We will be back again next week at around the same time. You can catch the VODs on the Twitch channel right away, or 24 hours later, you can catch them on the YouTube channel, Apple Podcast, Spotify, all the common places for, podcasts. We're pretty much there. You can check out the community as well. We have a Discord that you can join. We have a links channel. If you have anything you want to suggest for like next week's podcast or anything like that, you can post those. We'll definitely take a look at them. And any questions that, you have that while we're not live, you can ask in the Discord as well, and we'll try to answer. But yeah, that pretty much sums up the podcast. We will be back again next week at the exact same time, 3 p.m. Eastern, 12 p.m. Pacific, and we will see you guys then.